Good morning, good afternoon, good evening. Hi, everybody. Hello. Hi. How are ya? Hi. Whew, so glad we're here. I am sorry we started so late. I just had the most wonderful moment. I got to pay off my taxes. Um, ooh, that's better than coffee. I mean, I love coffee, so I don't say that lightly. But that was really good. That's fun. I work and well, I mean, for now, who knows with this economy, how bad everything will get. But right now, I have a job, and I work in Silicon Valley, and in Silicon Valley, uh, you know, they if you have a job, they withhold from your paycheck, and the more senior you get, the more significant a portion of your withholding is in, or not withholding. It's the more significant portion of your remuneration, your pay, comes from like stocks, which is a gamble. You don't know if it's going to be good or bad, but either way, it means that every year your income isn't quite the same, right? It goes up and down with the market, whatever that looks like. So every year my taxes cause me stress because I don't know how much I earned or how much I will earn in a given year. So taxes, oh God, but it's good. They're all paid. Everybody's happy. No problems. Good morning, everybody. Hello, hi, good afternoon, good evening. I am so excited we're all here today. It's good stuff. I technically have the day off, so we'll keep this quick. Today's the day off for me. And oh yeah, the Silicon Valley Bank thing is interesting. Yeah, I don't know what that implies. Um, it looks like I saw yesterday. Was it yesterday? I saw the federal government. President Biden and his administration will contain um, the fallout, I guess, from Silicon Valley Bank. I don't understand the situation very well. Somebody explained it to me as follows, and I don't know if this is correct. Um, Here in the United States, interest rates, as is true for a lot of the world, here in the United States, interest rates are going up, and that means that it's expensive to borrow money. If you want to borrow money, it's a higher percentage, right? So if you want to buy a house or buy a car and you want to use a loan, then you're going to pay the principal plus a very high interest rate. And this is not true for the last 10 years. This was not true. It was very cheap to buy things in the United States. Very, very cheap. Almost free. You can almost get a loan and pay basically nothing, And so people were buying, they were spending and buying and loaning and so on. It was like water. And so banks, they have all this money that they're given, and they want to make money off of the money. So they take that money that you put on deposit, and they play in the market. They gamble with your money, basically. And this bank gambled by buying bonds. Bonds are like instruments that have value represented by the U.S. government, right? And those bonds were for a low 1.8% interest. Well, now, that means that if you put your money in that bank and you want to get money, you want to have interest for the amount that you put in the bank, you're only getting 1.8% because they bought those bonds a few years ago, and that's very low. But today, a bond, if you get a bond today, it's like 5%, right? More than 5%. And so basically, if you're a person who puts money into the bank, you're 3%. You're not making like 3% interest. You could be making 3% if you went to some other bank. So that's part one. And then because people were, I guess the bank sold, or they did something to sort of get rid of the old 1.8% bonds and move to the new more interest earning ones. But that scared investors, and then investors started telling people, and then people started withdrawing all their money very quickly, and this created a run on the bank, and the bank on last Friday, they realized they don't have, if they kept going, if they kept letting people take their money out, they wouldn't have enough for everybody. And so I guess the federal government stepped in and shut it down. And this is a big deal because it's a local bank. It's a local community bank. They didn't shut it down. They took control of it. That's the right way to think about it. They fired the old executives, but now the federal government is in control of the bank. And this is a big problem because, well, it's not a problem, but it's a big deal because that bank holds money for lots of local Silicon Valley companies, right? Big companies put their money in there for, paying their salary, paying the employees, paying, just storing the money, And in this country, if you have, I guess it's $250,000 or more in a bank account, the federal government guarantees that you will not lose $250,000. But if you have $1 million, then you could lose $750,000, right? It's so if you're a giant Silicon Valley company with 1,000 people or 10,000 people or whatever, then you definitely will have more than $1 million, more than $250,000. And so if the bank collapses and there's no money in the bank and they lost money from their investments, they don't have enough assets, then in theory, everybody in that bank could lose anything above $250,000 in deposits, right? So people are scared. Oh, what happened? Maybe we don't have enough money to pay our employees and stuff. But so far, it looks bad, but everything I'm seeing makes it look like it's going to be okay for these local businesses so far. Not any huge ones. I haven't heard about any huge ones. I heard about Roblox and Roku, but again, I guess they're okay. So the problem isn't Silicon Valley, right? It's just that here we have a lot of people with a lot of money. The problem is the interest rates are going so high. So all banks are they are sensitive to high interest rates. They are sensitive. They're not sensitive. They're sensitive to if the interest rates are here 1 year and then the next year they're up here, right? That's the problem. Very, very quick changes. They can't react quick enough. I guess. I don't know. I definitely am not an accountant. I fear money. I write code. It's so much simpler than understanding banks. So anyway, that's the explanation somebody else gave me on the internet. I don't know if I'm wrong. I could be very wrong. Forgive me if I am, but it made sense when I heard it. Okay, friends. So today, let's continue our journey for Kotlin. I'm excited about this today. We left off having looked at functions before. So let me share my screen here and clean up a few things here quick. Share my screen. All right. Okay, so I've reset the application, right? I've been playing with it, but basically here we are still. Can you see that font? Is that? Let me make it a little bit larger. Okay, so where did we go? Where did we leave off last time? Last time we looked at functions. We looked at how functions are a first-class citizen in the language, and we looked at how you could pass functions around, and that led to some very interesting things. We also talked about variables and how you define variables of certain types, and I said that the language very strongly prefers immutability, right? It wants you to write val, right? The val name. By the way, I am still learning this new keyboard, right? My keyboard. So val name, and if I wanted to change this, I can't, right? It doesn't let me. I have to make it var, right? And so let's see here. There you go. So var, and you should not use this, right? The language. Look. IntelliJ is telling you variable. Well, here if I. It's telling you that this isn't going to work, right? Look at that yucky underline. It's telling you something is wrong, right? It wants you to use val. the language very strongly encourages val. And you might be thinking, well, what if I want to change something? What if I want to start with a state and then continue changing it, right? And a common example of this might be like a database, right? So val db equals data source, or yeah, let's just say we have an embedded database, right? Embedded database builder set type, and database type will be h2. Okay, and we want to say build, right? So I've got a database at a data source there, right? And I might want to build a JDBC template. Val JDBC template, and this takes an instance of that. So JDBC template db, and you could do things to this, right? There might be setters and properties, but one of the nice things is that there are these nice hooks, right? So like I have to call after property set. I could do that. I could just say JDBC template. JDBC template dot. I could do that as well. But the nice thing about this is if you want to keep mutations on the object, or even just interacting with the object to a minimum, if you want to isolate that, you can do that very naturally in Kotlin, because there are a lot of functions here that you can use to act on the object after it's been created, and they're just sort of like, they make it very simple to chain things. So here, oh, thank you. Hello, hi everybody. Oh, yes. Hello from Istanbul. Hello. And thank you very much. I hope we have a nice stream as well. I mean, it's Kotlin. What could go wrong? It'll be fine, But I appreciate that. Okay. So we have this apply method, right? And this is very interesting because notice that when I say this, when I say this, I have access to all of the methods on JDBC template. So this, the receiver of my apply call, is somehow the JDBC template that we created up here, right? So this is one of those things that's kind of mind-bending to think about. You can do this in JavaScript. You can change the receiver, but you see what's happening here? We are passing in a lambda. It's a function. The function doesn't take any parameters and it returns unit. And we'll talk about unit in just a second. But what's important is that it's taking a receiver, right? And that receiver is T. So you can create your own receiver, your own type, your own method. And that receiver, that's the thing that will be this, right? So the lambda is called block. And you can see when you call calls in place, right? And it in turn, where is it? Public, contact DSL. Well, when you call apply, it's passing in this to your lambda, your callback. So let's see, where is a good example of that? Okay, calls in place. How do I block this? So see that right there? So you're passing in lambda, but it's passing in this. Let's see. Oh no, where is it? Block calls in place contract block, and the well, I guess okay. So with this value as its receiver, yeah. So that's you can specify custom receivers for lambda methods. There's also another one here, which is maybe a little bit more easy to understand, which is where you just get a callback with it. So also, in this case, I get a pointer to the database template, and I can do what I want with it like that. Now, one thing that is kind of interesting here is this is an implicit variable. It's not. Sorry, it's an explicit variable. I'm saying when I have a lambda, I'm passing in a lambda here. And the lambda, I'm doing this the wrong way, so you can kind of see what's happening here for people who have just joined. lambdas can live outside of the parentheses, so it could be like that. And also, you don't need to specify the parentheses at all. And so I've got a pointer to JDBC template right here. Well, in Kotlin, you can, if you have just one single parameter being passed in, there's an implicit variable called it. Okay, and it you might have recognized this from Groovy. So here I'm saying after property set, it is equal to JDBC template. So it makes the code a little bit nicer. But the question then is, what if I just didn't? What if I could just say this? What if I could just call methods as though I was inside of the class itself? And that's what apply does, right? Is apply lets me just call that. But now I'm acting on this, but I'm calling a method as though I was inside the body of that class itself, which is pretty crazy, right? So now I get this very nice sort of functional pipeline. And so I'm making a change to this. Apply returns this. So if I wanted to, I could keep applying. I could keep applying. I could call something else, right? I could call whatever. So if you have, I still have val, but there's no reason I need to change it, right? Because I can always just use these methods to change chain operations against it, right? I don't even have to do that horrible thing where, like, one thing I don't love is, even in Spring, we have all these great objects. A lot of them take setters. You know what a setter is, right? Like it's a field that you can call set foo, set bar, etc. I like to keep all of that inside of an also or inside of an apply, right? So that way it's very clear. This construction logic lives with that. And if I want to change it, I can move the whole thing. It's very nice to have it all in one place. So if you have complex construction that happens after the constructor, all of that can happen inside of either .also or .apply. Okay, so it's very easy to, because of this, also, you can assign variables like that, right? You can do complex computations and say, okay, well, maybe let's say I have a, well, let's go back to here. There's other built-in methods, right? There are methods that you can see. Let's see, also apply. These are both for Kotlin. Let's see, these are query. This is all part of the JDBC template. Run, take if, take unless. So run, what does this do? This is calls with this value as its receiver and returns its result. Okay, so here you can chain operations together, right? So yeah, so basically, bonjour, Josh. Oh yeah, hi, bonjour, hi, nice to see you. Yeah, it's just an amazing like language that what we're doing here. Okay, so run, I can change it basically. It calls the specified function block with this value as its receiver and returns its result. So here I can actually say that I want a number, right? If I look at this, okay, and so if I look at the type of number is run this again. It's 1. So it created the JDBC template, but the value assigned to number was 1. So I did the thing here, but then I changed the result to this, which maybe you want to do, maybe you don't, right? Maybe you want to create this object, do .also or .apply to update how it gets created, and then do something with it, and like if I wanted to call this .query, I could say query blah, and then those results. Maybe I care about the results, right? I can do results. So maybe the result of this .query, right? Or I should, let's see. Record, what's our data class? Customer int. Right, so okay, so maybe I want to do blah, and then I want to say it's a returning a customer. So I can say the type is customer, right? Come on, what's the issue here? Let's see, query. Do I have to pick a row mapper? Is it not extending that? Query row mapper, query string, row, query for list, is it? I just want like, there, okay, so I'm turning that. There you go. So in this case, the results of this are the actual results of the call to query, right? So you get this very nice ability to chain operations together. Let's see, apply after property set. So I'm calling database template, I'm initializing it, and then I'm using it to call to run a query, and then I throw away the object. So the results that get stored here are actually the results from query for list. I get a list of T, right? So I get this right here, list of T, okay? In this case, list of customer, which is the data type we're passing in. Okay, so it's very, very concise. I love that about it. Like, you don't have to use var. It's almost never to use var, right? You don't really need to like reach for it. Sometimes I go out of my way to avoid var. Sometimes I don't know how to solve the problem, and that happens a lot because I'm not very smart, you know. So sometimes I'll sit there and I'm like, there's probably a nice functional way to do this, but I don't know how to do it, and I still want to keep my val. So sometimes I'll just use an atomic reference. You know, that's how dedicated I am to avoiding var, right? I'd much rather have yeah, exactly. All these Kotlin features incentivize functional programming, and you can chain them together, exactly. And by the way, this is like what's in the language, right? There's actually a really nice language, a nice set of libraries called Arrow, right? So Arrow, Kotlin, okay, Arrow KT. And this is what you would do if you really wanted to go all in on functional programming, right? I don't, you know, this is not my particular area of expertise or forte. It's not my forte, but you get like all the stuff that you want from a nice functional language. This gives you much of it, not all of it. I hear from people that are in Scala that this isn't quite everything that they want, but it's a lot better than what you get out of the box. I don't know. Don't ask me. This is not where I spend my time. So yeah, kind of looks nice. I've tried it out every now and then, but I just don't know what I'm doing, so I just leave it alone. But you can try it, right? Really interesting options. Okay, so we've got variables. We looked at apply. We looked at how we can work with mutable state in an immutable way, nice, safe way. And we're also, by the way, notice that we're not polluting our namespace, right? Our main method has 2 variables, right? That's it. That's all you need to know. We created a DB, we created a result, and we're just doing it in this nice, clean way where we've got that. This is kind of interesting, though. This after property set returns void, and that reminds me we should have a conversation about void. So in Kotlin, fun do nothing. Okay, and so I didn't define a return type there. I didn't say it's an int. I didn't say anything. So when you don't define a return type, it's implicitly unit. Okay, it's returning something called a unit. But unit isn't the same as like void actually means 2 different things in Java, right? It means this returns no value so that the code will run and it does its work through side effects. The other thing you'd use void for is to say this code doesn't return, right? So for example, in the, let me see, run application here. This one, not that one. That does return something. There's a what's the one that we have in Spring? Gosh, Kotlin doesn't return alternatives to void. Nothing. There you go. So nothing. Where did I see that though? Where did I saw that in? well, whatever. So if you have a function that's just going to block, for example, it's going to just sit there doing something forever, right? You would return nothing. And there's a great example of this. This type. Yeah, for example, if a function has a return type of nothing, it means that it never returns, always throws an exception, right? So it might be doing a while loop. It might have like a run loop that does rendering or something. And so you can use unit, that's 99% of the cases, but on some cases, when you're trying to say, I'm going to do nothing, I'm just going to block, right? Then you just return that, right? So like, and by the way, notice that the language doesn't care. Like watch, if I do while true, right? Notice that it's smart enough. Come on. Notice that it's smart enough to know that there's no way this is going to return. So it doesn't, I don't have to return nothing. My code is still valid. I never have to explicitly define nothing. I'm trying to remember where that, where the thing is. Oh, it's the to-do macro. To-do. Okay, so to-do. There's a great macro in, is this it? No, that's this one. To-do. Not yet. No, classes. To do. What am I thinking of here? It's let's see here. Let's try this. Start that string.io. Where did we see it? Kotlin, Gradle, Kotlin, control space, great source demo. No, is it a test? Oh, we used to have it somewhere. There used to be a place where it just got, is it in Kotlin itself? Whatever. The point is you can, the language knows you're not going to return, and so it doesn't get mad at you. This wouldn't work in Java. You would have to return null or something, even though it'll never get to there, right? Comments to do, right? Is that right? Yeah, that looks right. But there's a macro there. It's not just a comment. It's a actual function that the language has, and it's amazing. I wish I could find it. What is it called? Kotlin to do. Okay. To do state fail. Yeah. Let's just try writing it out. Maybe you're right. Maybe I just need to do that. There you go. Why did I searched for like 5 different ways and it didn't come for it, but here it is. So this function returns nothing. Okay. All it does is it throws an exception. There's no way for it to do anything else. So the return type, even though we're never returning nothing, the return type is nothing. You don't explicitly define an instance of that. You just define it as an error, as a return type, I mean, and then you do something such that you never have to return. And the language understands that. But this is inline. Notice that. So watch this. I go here, and I can use to do, right? I'm going to use to do to say, you know, well, notice that the language doesn't care. Let's say I return int here, okay? Notice that the language doesn't care that I'm never returning an integer, right? It doesn't care because it knows that this type has a return type of nothing. And it knows that nothing is only used when something is not going to return. It also knows that this is inline. Notice that? So it says inline function. So this is actually what's basically being copied and pasted there is this. What we're basically getting when we run this code, when it's compiled, is we're actually getting this code copied and pasted right there. And so this is passed in to this, right? Basically. So the language is, you can do some amazing things. So we've got this function that doesn't do anything. It doesn't return. You're not calling return, and yet somehow the compiler is fine with this. You can't do that in Java, right? If you have a function that returns an int, but you don't return int, even if it's -1 or something or 0, then the compiler will complain at you, right? But we have this nice mechanism for signaling, hey, this is not going to be due. It's never going to return, right? this code you couldn't write this code in Java. And I just think that is one of the nicest things in the language, is this intelligence about unit versus nothing, okay? To do. So, okay. That took a minute to remember. I don't know where I saw that. What is it? Maybe we used to generate it in the Spring Initializer or something. I don't remember why I remember this, but I don't use it myself very often, but it's just very nice to know that I could. Okay. So let's try that. Let's try a function. Like, let's just try that fun no return, right? Whatever. We're just going to call it no return. Returns nothing equals throw illegal whatever. Okay. So if I do that, does that work as well? Let's see. No return. Or is it the yeah, that works. It's not even inline in this case. The inline in the previous example is just an optimization, but it just, because it's nothing, right? If I said this is a unit, then it would return. It would expect it to return, and the compiler doesn't like that, so it says something's wrong. But if I do nothing, everything's fine again. So nothing is like void for most intents and purposes. When this gets compiled, this still says void. The function in like bytecode returns void, but the compiler knows to treat occasions where it sees nothing as kind of special. So you get this really interesting like ability to stop a function dead in its tracks, you know? Okay, what else? So we got variables, we got smart functions. We talked about functions. We talked about creating variables and talked about chaining their mutations and operations together. Let's talk about classes themselves. I should mention that Kotlin it was designed to be familiar to Java, and so a lot of the paradigms are the same. It doesn't introduce, I mean, maybe coroutines. I don't know. I don't think it introduces any major new paradigms. It just sort of simplifies things, right? Like .apply and .run are basically just new methods on Java lang object. They call it ini, right? The base type is called ini, but like it's not unheard of to have methods in the base type for a language. That's not special, you know? Having functions that return, I think this nothing is kind of special, but basically, if you understand Java, you can understand Kotlin. There's some nuances there, but there's no like major paradigms. And so when they find things that are familiar to Java developers, they didn't really break or change those exceptions or expectations. They just did things that sort of naturally fit with the way people think about those paradigms in existing languages. And this goes back to what I always say, which is that the Kotlin team has done so much work to make this approachable, right? Just make it familiar, make it like the right choice for any paradigm as opposed to the best choice for one paradigm. And so I think of it as being a very pragmatic language. And very few languages I know of work like this, right? Because the common wisdom is you can't be Java, right? It's impossible for any language to be the next big super language that does everything, right? You can use Java everywhere except for big data at this point, right? And even there, it's used for the infrastructure that powers big data. But now, you know, you've got this thing, and it's not trying to be the best at everything, but it's trying to be the best at so many different domains that it's I don't know what the distinction is. I don't know how to like think about that. It's just crazy to think of building the next big systems language, you know, or general purpose language. Very few languages can do that, and it takes a lot of like skill to be able to even come close to that. I don't think they're doing that. I think they're trying to build a language that works very well for a set of very important domains, right? So server-side JVM programming, of course, with the native stuff, they're going to get mobile. They've got iOS, for example. With the JavaScript stuff, they're on the web, in the browser. I mean, they're just really good at certain domains. And to do that, while still just improving ever so slightly on existing paradigms, that's pretty amazing. A lot of languages, they go very specific. They go straight into a new paradigm, and they focus on one thing. And they're happy to have 100% of that particular pie. And then, to be a big fish in a small pond. Java is a big fish in a big pond. That's hard. That's really hard to do. And Kotlin, I don't know how it's doing it. I don't know how it can be paradigmatically very similar. So when it's very easy to say, oh, Scala is just like Java plus or something. Scala has its own paradigms. It is functional first, right? And object oriented, but it's very, very clear they want you to be doing functional programming. The community, everything that flocks to that language is using it because they expect to get access to all that great functional community. Here, however, it just feels like somebody wants you to be using Java, but with some nice modern, benefits. Okay, and it's just very clear. The little things like this add up, and the result is just much bigger than any of the individual pieces. The sum is greater than the parts. Okay, so we've got this function. Do we talk about objects? Yeah, let's talk about objects here. Okay, so create a class. Good. Okay, so you already saw this. This is nice. This is a data class, and this is what records are inspired from. In Scala, they have case classes, so case class foo or whatever, etc. That's a very convenient way to get an object that has a toString and equals a hash code, getters, setters, etc. But you can define regular classes, right? Like so class hat, right? If you have a class that has no body, then don't specify the body. You don't need to. It's not required. Okay. So your normal stuff works as well. So you can say interface animal, and I want to extend animal as an interface. Notice that we have a unified interface here, right? If I want to implement an interface or if I want to extend a class, so class, I don't know, whatever, maybe that's so I want to extend feline. I need to create the constructor. I need to override the constructor. This needs to be open. Okay. There you go. But notice that it doesn't care that I'm subclassing a class and implementing an interface. It's still just colon, right? So it's doing the same things. This kind of reminds me of C# or C++. The uniform approach to inheritance, right? If I'm extending something, I do it in the same way. I don't have an implements or extends keyword. Is it a big deal? No. Does it change whether one language is better or worse than the other? Probably not, right? But it's just small stuff like this. I love it. We talked about open classes, right? We have to have, so everything is final by default. You have to ask the language to let you open the types of subclass. Okay, so let's load that down. There we go. So as you can imagine, in a language in a technology like Spring, where things are being, you get subclasses all the time, proxies and so on. This is a big deal. This fact that things are final by default is kind of an interesting thing, and we'll talk about that in a bit when we get to Spring. But just keep in mind, there's this dynamic where things have to be opened. Okay. The other thing is, I can create constructors. So I might want to create a constructor, and we already saw that you can do that kind of with the inline constructors, right? Why is feel? Oh, because it's calling the constructor. You mean this right here? Yeah, it's calling the constructor. I was about to get to that. So let's suppose that my class has a constructor argument called name. Whoops, name. Okay. A lot of times, so this is your default constructor. This is your primary constructor. You have this thing in the class definition itself. Here, I'm creating a constructor argument. Well, what am I going to do with this constructor argument? I'm going to probably, if you think about Java, right? I want to take the constructor argument and then assign it to a variable. This is such a common thing, however, that, again, Kotlin has a convention for this. If you want to take a constructor argument and assign it to a variable, you can say var name, in which case this constructor argument now becomes a field. Okay, so if I go here, let me see if I want to, whatever, Felix. Okay, so I can say val so new at this keyboard equals. Okay, so if I want to print it out, I can say print cat dot name. That took like a week to type that, but we did it. We did it. Go team. Okay, so here we go. You can see I can dereference the field here. I can also change it. Cat dot come on, cat dot name equals Garfield. Right, so okay, so I can change the thing. But what if I don't want the field to be changeable? What if I don't want it to be mutable? Well, I can do val, in which case this is no longer allowed, right? So if I do that and I run it, there we are. I get the, I can read the variable, I can read the state in that field, but I can't mutate it. Once it's constructed, it's immutable, which is exactly what you want, right? So, okay, so we've got this very nice mechanism where you can create, how do you create a cat where you don't know the name yet? We'll just override it, right? So name. Oh yeah, yeah, you can do super calls. Yeah, exactly. So pass in name, right, like that. There you go. So now, there you go. Make sense? So what this is my cat constructor, and I'm calling the super constructor passing in name, right? So this is, if I change that, it doesn't compile it. See, it's referencing variable there. Right? Does that help? Yeah. So it is a little different, right? But imagine how much boilerplate most Java classes have when they're doing something very simple, like I just want to call this class, override the constructor, and then override one method. Well, the one method is what I care about, not the nonsense of like taking the data from my constructor and forwarding it to the parent constructor. That's just this very clean one-liner thing, right? So let's say we have a talk unit, right? Fun. I'm having so much trouble with this keyboard, my friend. It's just fun. Okay, so I don't even need the unit, by the way. So there's my, now I've got this, I've got to implement that. So implement this. It says override. Notice that, oh, this is where it came from. Does that mean that when I inherit in Kotlin at the signature level, I need to pass in all the arguments that the class constructor requires? Yes. Yeah, but that's just like with Java. You can't, or you can, you can just pass, if your parent thing expects null and whatever, if it accepts that, you can do that as well. But yeah, generally when you have a subclass, it needs to call the superclass to put things in a valid state. Yes. Okay, so I've got this, I'm now overriding, I'm implementing a method here. And this is where that macro I was talking about earlier was, to do, not yet implemented. Okay, great. So whatever, I can, yeah. Yeah, okay. So, and maybe I can refactor this to be a mammal, whatever. Okay, so I've got cats and they're mammals, and mammals can talk. They can say things, bark, meow, moo, whatever. So that's pretty straightforward, right? I think we're all basically on the same page here. The question then becomes, what if I want to do something with the constructor arguments, right? So let's say I have a variable. So private val name string, right? And let's see, what is the, oh, it hides this. Yeah, that's true. So let's say dash, whatever. Let me see, my, yeah. So now I've got a field that, well, it's a not mutable. It's not nullable. I mean, so I can leave it like this and assign null to it, right? So I can do null. That's one thing. I can leave it like that, but then I have to assign it something, right? I have to assign a variable to it. If you want to change things, however, if you want to act on something, then of course you would want this to be nullable, right? Like that. And then nullable. Then you could create a constructor, an init block. Okay, so init is where you can operate on state. So you can say, okay, if name dot equals whatever Felix, then this dot my name equals whatever. You can do something like that. You can actually do logic, initialization logic on the primary constructor in this init block. Okay, so I don't normally need to do this. In fact, I go out of my way. Like if I find myself writing this and this, then maybe something is wrong. You're going to have variables, right? But again, if you've got how would I do that? I could say, okay, name dot run, right? And I could say, okay, so what is this? This equals Felix. So you could do the transformation in line, basically, right? You could do all those things that we saw earlier, and you can make changes as a result. So you could return whatever. You could say, okay, I want to return cat Felix. Otherwise, return this, right? So whoops. If what is the issue? If this else this. Oh, come on. Okay, that's a little ugly, but so you can replace it with that. Oh yeah, that's another thing. It gets equality right. Okay, so now instead of me, I don't need to make this immutable, make it mutable. I don't have to do that, and I don't have to do this either, right? So suddenly I don't need this. That run, that apply, all that stuff that we saw earlier, it goes away when you start using these chaining operators. So I can act on the constructor and initialize variables like this. And so if you need an init there, but still, because you have some sort of life cycle thing that requires two different variables, then maybe that's what you do, right? But a lot of times you can get away with just initializing simple queries or simple questions or evaluations. You can do just by using also, apply, run, etc. Okay, what else? I'm just trying to remember what else we would need to think about here. Oh, the main constructors, secondary constructors. So what is all this? Test data. Wow, I've never noticed all this before. Is that just for Kotlin, I wonder? Okay, what else do we want? So we've got an open class. I want to generate. Oh, let's see. Class person. This keyboard. Okay, so secondary constructor is this thing right here, right? And this is like an alternative to the main constructor, and you can do full-on logic in there as well. I don't know. Do I care about this? I don't really care about this. I don't even use it very often. I'm sure it's useful because of interop, is in my perspective. What is going on with my keyboard? Name, string, whatever, and then you can assign state to something. So private val, my field, string. I want it to be nullable. I want it to be null. I want it to be var. There you go. You can do that kind of thing, right? My field But again, I just find a lot of time. Oh, come on, Josh, you can do this. There you go. So I find I don't really use the main constructor a lot, so I feel like I'm not really, I don't know, I'm sure you'll need it. Just know it's there. Most of the time you can get the job done with just this primary constructor syntax. And that mixed with this functional chaining, you can initialize a lot of the things you would have had like a main long constructor with a lot of like if else this, that, whatever. A lot of that goes away if you just do this, right? And so I don't know if you really need that kind of approach. What else do you need to know about objects? I'm sure we'll discover something. Objects and interfaces, pretty straightforward, I guess, is what I'm trying to say here is if you're used to Java, nothing will be very surprising here. It's just cleaner. I guess that's the important part. It's just very cleaner. Oh, also, notice that if and else are expressions, right? So like val result equals that. And notice that I can do just return result, right? Oh, companion objects. Yes, thank you. So if you want, so that brings us to the question of this. By the way, look, see that? Isn't that's not a ternary? It's not a binary like a ternary operator. I'm just assigning this the result of this if else to a variable, right? Which I quite like. So that's another thing is if you wanted to do these like this is a string, right? The return value of the if else is a string, and so imagine you could do like that, and then on the string you could do apply, right? Or also, or whatever, or run if you want to like return a value and chain the operation. So I can return another string like that. Okay, so I can do if else in as an expression. So another reason why you don't need a constructor, because you can do while loops and things like that. Well, not while loops, but cases and if else, that can be done as an expression, and you can assign it to variables and you can chain them together as well. So again, you don't really need a constructor for a lot of use cases that you would have otherwise needed it in the Java world. Okay, companion objects. So we haven't talked about static. I mean, we kind of talked about it. We talked about JVM static, whatever, but that's not really how you would do it, right? So if I wanted to create a companion, so object, whatever. Okay, object. Cats, whatever. Come on, right? So then I can have a function here, right? Function. I don't know. Build, whatever, right? I can build a new cat, and so this cat, this companion object is static. Basically, it's a singleton. It only exists once per your code base, once in the code base. You can't instantiate an instance of it. You don't need to. It's just it's a well-known thing. Whatever, pass that in. Okay, so I can now go here towards my main function. I can say, okay, I'm gonna val nc equals cats dot build. Okay, so it has the benefit of being a nice place to put things like factory methods, right? The things that you would have otherwise put in a static object, you can kind of do that here. And like I said, there's a way to, you can kind of get around that by using @JVM static, the annotation, but this is just more natural. You'll see this a lot, right? You'll see this a lot. Actually, one of my all-time favorite uses of companion objects is in a object relational mapper called exposed, which does, it gives you companion objects that you can use for creating queries and working with tables and all that kind of stuff. Maybe we should talk about exposed as well, but not right now. We still haven't got any. I'm trying to avoid, as much as I love Spring, we're avoiding Spring just for now. We're just looking at low-level Kotlin just so we can all kind of like explore the basics here. I don't know what else I need to talk about for objects, though. I feel like we've covered all the important stuff, and we're going to have to get into, in order to do anything useful very soon, we're going to have to look at frameworks, right? But anything else I should be talking about here for Kotlin objects? We looked at variables. We looked at functions. Yeah. So let's clean this up. Oh, I think we talked earlier about receivers and this kind of thing. You can write your own functions that do that, right? So fun, do with, and then I'm going to create a callback, and the callback is going to be typed to whatever. Like let's say I have a class here called my template, right? Whatever. I can say that the callback is the receiver of that callback is my template, and it'll be any function. It'll be a function that accepts no parameters and returns a string. Okay, so that'll be the callback. And then with the callback, I can pass in my template, right? So when somebody uses this, I can say do with. I can pass in a lambda, and here, like let's say I have this variable here, val field equals black, whatever. Now when I call do with, I can print out this dot field. I can get access to it. I can enumerate it, right? So print line. Here we go. I forgot about that. What is now the issue with that? This dot field is a string, which is fine. Wait, what? Do with, oh, returns a string, right? Okay, yeah. So, blah. Oh, by the way, just like Ruby, the last line of the expression, the last line of the lambda is the return value. So here I'm just returning string, but doing that is the same as doing this, right? And you can see it's even asking me to qualify where I'm returning from. I'm returning from this lambda, not from main, right? You have to like scope your return, which is kind of interesting as well. So a lot of times the right thing is just to do that, just to leave the last variable without a return statement. So the return value. Oh dear. Okay. Okay, so I think that's it. Is that pretty good? Any questions on this stuff? It just kind of gets obvious when you start using it, I guess, and I kind of want to get into the point where we're using it in practice. Any questions, thoughts, feedbacks? And yeah, I could probably just use it in case I don't need this. Okay, let's move on. Let's talk about coroutines. Okay, this is where things get a little mind-bending. Okay, so we talked about how there's not really a major new paradigms. The one exception might be coroutines, and even that isn't necessarily mind-bending if you've come from some other language like Rust or Go or C# or JavaScript or Python or all sorts of other languages. I think Ruby has something like that, right? Excuse me. Even Scala has fibers, I think, of a fashion. So it's not necessarily, it's not like it's paradigm changing or brand new or whatever, but it's just really interesting. And basically, there's a nice way to work with threads. It's just a nice way to work with threads in such a way that you can write code that looks and feels imperative, and yet is taking advantage of the benefits of having well-written, interleaving concurrent code. And so there's some low-level stuff, like you can use, let's say I want to do, runnable one, okay, print line. So starting at thread.current thread, okay. So I've got this function, and I can say stopping oh my god. How do I delete? Oh no, that's not it. How do I delete this variable? No way to delete. I have to. Oh wait, there it is. Okay, wait. Okay, that worked. Okay. Command Shift 8. Can I do that? Yep. Keyboard is satisfying. When I succeed with the keyboard, I feel like I've done something amazing. But I don't get to succeed a lot. Okay, so fun, runnable 2. And that, okay. So I've got 2 functions that I want to run. In order to do this non-blocking coroutine centric stuff, you have to have a context in which to behave, in which to act. And somebody has to inset that, right? So usually you're using a framework like Spring. Spring will create that context for you. But if you're in just public static void main and you are the top level piece of code, you should probably start that up. And so one of the easiest ways to do that is to use a run blocking. And then, if I run runnable, okay, and then 2, and then again, what do we get? Okay, so as expected, everything's on the main thread, okay? I can use operators, I can use methods rather, in the library, in Kotlin, to run things. So let's see, launch. Okay, and if we look at launch, let's see what that gives us. Still inside of that. I want to run this in a different thread now, okay? So launch takes a coroutine context and what is it, dispatcher or something? Dispatcher dot default dot main, whatever. So let's run that. Oh, main you can't use. What about IO? Okay, restart. There you go. So you can see I called start, and then it immediately moved that to the background, right? Because it's on a different thread. And then it called start again for the second one. So starting, I guess this is 2, sorry, 2, and there should be 1. Okay. Okay, so I'm calling starting 2, right? Because it actually forked 1. It moved it over to a different thread pool, which meant that the main thread kept going, and it moved pretty quickly. The main thread started number 2, which I didn't put on a separate thread pool. I didn't put on a separate dispatcher. It started number 2 before it started number 1, because number 1 had to spin up a new thread, and then it got moved to that thread. So number 2 started first, and of course number 2 finished first, and then number 1 finished second. But you can see number 1 finished on a separate thread pool, and that's because we changed this context, this coroutine context, this dispatcher. You can turn a regular thread pool. How do you do that? Executors. Let's just try it. Executors. To fixed whatever. Coroutine. That's coroutine dispatcher. Okay, and then you can say I want to use with. Right? No, what? Not with. What do I do here? Executor. That's it. So what do I do with this? Is this it? Val. Executor equals that. I think I can put that launch. Okay, that goes there. And then executor in here. Yes, okay, good. So let's try that again. Okay, so now you can see it's still on, so 2 is still on the main thread. Why is that true? Launch executor, what does it take here? It takes a context, runnable, as a coroutine dispatcher. What is this? Executor coroutine dispatcher. This takes a context into coroutine. Does that in turn It implements execute coroutine dispatcher and delay. I don't know what that is. Coroutine dispatcher. Why is that? Oh wait, no, that's a pool. Was that the same one as we had before? Let's try getting rid of that for a second. Let me just see what happens. It says pool one thread one. Let's see if that's what it still says. No, different. So it says main. If you don't have that, okay, so that did work. I would just psych myself out. So there you go. You can see we're able to create a coroutine dispatcher using any thread pool. So any standard executor that you can get from Spring or from Java, you can turn into a coroutine dispatcher and then use that as the context in which these things run. So this is not particularly special. It's not like we're doing anything that you couldn't do with just runnable and thread and a regular executor. It's just nice to know you've got this nice mechanism. Now here, launch, doesn't that give you a job? Yeah, it gives you a job, right? So job for launch equals this. And I can say job for launch dot is active. I can cancel it. I can start it. So this is kind of like a thread. From that perspective, you can ask it questions, but it doesn't give you the result. If I want the result, then like, what if my runnables? What if this one was doing something long running, right? I wanted to get return, okay, and I can say string, okay, return some long running value. Okay. If I want to get the result, what do I do? It's not launch, it's this is the launch functions. Coroutine launch async, that looks right. Async deferred of t. So we say async instead. So instead, I can say val result equals async. Runnable, this one, runnable one. Okay, so what is this value? This should be equal to a string. Okay, is that wrong? Oh, it's deferred of string. That makes sense. And once you've got that, you know, you can await. You can say on await. Or you can just call await, which is like block. But the difference is this doesn't block. This is a suspend function, and this is the first part where you start to see the language is not just doing another threading library, right? In this example, it's not super useful. I mean, we can try it. Watch this. So let's see. Let's go here. Runnable. We're gonna do thread dot sleep. Okay. Or actually, there's a coroutine sleep, isn't there? Yeah. Is it just sleep? How to sleep a coroutine Kotlin. Delay, that's what it is, okay? Because again, this is kind of arbitrary. You don't do this very often. Delay, and then this has to become a suspendable function. But what I'm doing is stop that, suspend. I'm saying this function can be interleaved, basically. It can do something, and then when it's not doing anything, the control can be returned to the main thread. The thread on which this was running can be returned to the main thread. And so I'm going to put this down here. Out. This thread might change between here and here. We might be on a different thread, right? So let's see. Java for launch async await, and this is. I could just do that, couldn't I? Guess not. So I want to print out the results. Run. Okay. So we see worker 1, 5, stopping. So starting 1 here. And then what does it say? Stopping 1, starting. Whoops. Oh, I called the same thing twice, didn't I? Yeah, let's comment this out. Yeah, it's fine. We don't need all that. Let's just keep it simple so I don't lose the example here. Okay. Well, in this case, it ran on the same thread. In theory, this could also be on a different thread. I guess what I'm trying to say. You need to, I suppose, you need to create enough load, but by moving it, by using delay, I'm giving the runtime a signal that, hey, I'm doing something that needs me to just sit here, but I don't need this thread right now, right? And in the meantime, if somebody else wants to use the thread, great. If you created enough traffic, I suppose that thread might be picked up again, might be used again, right? But in this case, there's nothing else vying for it. So I guess the scheduler just gave me back the same thread. Okay, and the reason this is so important is because there's a whole host of functions that you can write where you tell the runtime, hey, I don't need this thread right now. I can yield, right? And actually, that's a thing you can do as well. You can yield in this function. Where's my runnable? Right. Another way to do this is to say yield, right? And this is telling the runtime, hey, like I said, yields the thread or the thread pool of the current coroutine dispatcher to other coroutines in the same dispatcher to run if possible. So delay is kind of like yield with some time, right? So you're saying delays coroutine for given time without blocking a thread and resumes it after a specified time. If the job is canceled, blah, blah, blah. So, okay, same basic trick, right? I prefer delay because it's kind of very explicit what's happening here. But the important thing is that you're doing all this work. You're using suspend to tell the compiler that you're going to do something that might have a suspendable, that might be started on one thread and finished on another, okay? And this gets kind of mind-bending when you think about it, right? Like we can do some pretty crazy things here. We're able to do non-blocking I/O in such a way that you're not actually writing code about it. What? Ooh. Hello, everyone. Seems like we've progressed quite a bit. I'll have to try to catch up a bit there. Yeah, we're making progress. I feel like I'm failing to. It's just really hard to understand or care about this stuff at so low a level. So what I want to do is I want to get into like Spring, some reactive stuff. We'll talk about reactive programming in the context of coroutines, because that's where it starts to really make a big difference, is when you can start using libraries that are designed with this coroutine magic in place, right? And in the context. So we'll look at that. I don't know if we want to do that today, or if we should just, I'm kind of like, it's a whole thing. Do we want to go into Spring Boot right now? We could. What else do we need to cover? Okay. Yeah, let's just quickly dive right into a Spring Boot application. Basically, you've got this mechanism in the language. You've got this new keyword called suspend. There's no other keyword, though. Everything else in Kotlin to support coroutines is library code. Yeah, we looked at coroutine scope a little bit, didn't we? We had the thread pool, the context. Oh, hold on. Hold. Ooh. Oh, yeah. Oh, yeah. Oh, sorry, friends. Give me 1 second. I just realized very important message. Yay. Okay, good. Some important business there. Yeah. Okay, good. So I think we're good. Wrapping it up in a bit. Oh yeah, collections. Oh, cacheable with Kotlin coroutines. I'll bet it is. Yeah. Has that been fixed? Yeah. Like that's a good point. I don't even know what that would look like because there's some weirdness here, and I'm sure we're gonna have the same issue with Loom as well, which is thread locals don't work the way you would think anymore, right? Yeah, that's interesting. What about collections? That's a good question. We do need to cover collections. I don't think. Let's cover collections, and I'll delay diving into Spring Boot proper till tomorrow, when we can spend the whole 2 hours on it. There's a whole lot of stuff with collections as well. What else do I want? I mean, there's just, first of all, practical stuff. It's nothing huge, right? List of, right, int, and you can just drop that 1, 2, 3, right, and that's implied to be a list of int, right? That kind of thing. You don't have to do all that much to get that to work and to understand it. Java now has these very nice, list.of and set.of or whatever, but this is here, a decade ago. It's awesome. I love this stuff in Kotlin. I expect they're going to work with Loom. I actually don't know. Let's Google that. I don't know what I'm sure there's going to be some lining of the stars here. So coroutines and project Loom. That's that's an immutable list, I should mention. Okay. So what do you mean versus? I don't know if there's a versus. Okay, friends, we're going to read some internet stuff together because I don't know the answer. And that's usually the true version. Yeah, actually, by the way, Jorge, that's a great point. The list of that I got back is immutable. The one I get back from Java is also immutable, but at least in Kotlin, I have a mutable list of, in which case I can get a mutable version. So yeah, you're right. This is immutable. In Java, you just get the immutable, and there's no other way to, as far as I know, there's no way to get like a mutable collection. Okay, so Java 19 introduced the first public release of the much-awaited Project Loom into the JVM ecosystem. Project Loom is an endeavor years in the making by the developers of the Java language. Okay, great. Beginning to weave. Naturally, the first question what I have is how virtual threads compare to. Okay, moving on. Java benchmark harness. Okay, with this Maven-based Kotlin project Gradle 7.6, Java 19. Hey, we did make it a first-class citizen in the WebFlux library. Don't give away the rest of the show. That's so rude. He wrote this blog back in December before I even started my YouTube channel, specifically knowing that I was going to land here 3 months later, and he was going to spoil the surprise. With the gradual introduction of Project Loom, though, the availability of a new multi-threading mechanism that is more performant than traditional thread raises the question of whether one should replace coroutine-dependent code with code that leverages virtual threads. After all, coroutines cause function coloring, i.e. they can only be called within a coroutine context or within a function that is prefixed by the suspend keyword, an issue that is not present in Java's virtual threading, and one less dependency on a project's code base in the task. I don't want to know about why coroutines versus Loom. I want to know if they work well together. What am I looking at here? Yeah, okay, I'm sure this won't be the case in the final thing, but if you saw our interview with Mark Thomas recently as well, there is a sort of tipping point before which or after which Loom's benefits are up for debate, and so in this, performance remains similar between the three approaches until the amount of launch processes reaches 6 digits, after which the virtual thread mechanism, Loom, begins to perform notably slower than Kotlin's coroutines, whereas the hybrid approach performed in between the coroutines and virtual thread approaches in the heavier tests. Rerunning the heaviest, okay, well, that's interesting. But so what we found and what Mark Thomas found is basically there's no difference with Loom and like reactive, but there is a big difference with Loom and like imperative traditional. I know, so Loom is the better choice there. Yeah, I mean, yeah, great point. I think that's what it'll boil down to, right? Is because that's the whole point. It should just be, hey, I'm going to swap out the thread pool and I get the benefits of this new virtual thread mechanism. But I would like to believe that, though I won't have to do that. I would like to believe that if I just call launch and it'll just automatically, instead of me specifically having to say dispatchers.virtual thread pool or something like that, it'll just plug in Loom all the time, right? Why wouldn't it? Especially since we have this nice abstraction on top of coroutines. Why wouldn't I want to just take advantage of the built-in mechanism? I don't know. There's enough library code that the framework could make sure that the code does what we still expect, and just be more scalable. I would like to think, but worst case, like you say, it'll be. I think it'll just be like launch. Whoops, run blocking. Launch. Dispatchers dots. I'd be very surprised if there wasn't like virtual or Loom or something, whatever, and then do that. Okay, so, but I don't know. Forgive me, I do not know the answer. I don't want to pretend that I do. You have different named different. It kind of happens with Android. You have differently named dispatchers based on the environment. Yeah. I should try, and that's the other thing is, I wonder. Yeah, so the coroutine library makes some conventional decisions for you. That's what I thought, right? That makes a lot of sense. The runtime that's in control of all this thread and that's orchestrating all the work that you're doing. It should do those. It should make those decisions for you, right? Same thing for Spring. I think at some point we're going to make it so that you can just plug in a virtual thread pool, and then just everything else is the same. You're just dispatching web requests on the virtual thread pool instead of not. I don't know. It's going to be exciting either way. Hopefully, most people won't need to change their code. That's the important bit, right? Is you get this free benefit. Just change the thread pool, and life will be good. Exactly. Yeah. Yeah. You can. Worst case, like Jorge says, worst case, it'll be what I showed earlier, where you can create the executor and turn it into a coroutine dispatcher. So you can create a virtual thread pool and then use that as the context. I'm not too worried about it. I'm sure it'll be fine, and I'm definitely sure the JetBrains team is already aware of this. They know of the opportunities and so on. They're ahead of the game. Okay, so let's see, friends. We got collections. Collections have mutations, right? Just like before. So you've got a map, but that's not a map from Java 8 Stream. That's a map from just from Kotlin's coroutines library. I'm sorry, from Kotlin's collections library. So this is a list, but it's not Java util list. It's Kotlin collections, right? And so Kotlin collections, and at some point you get down to like aliases, basically. So you have mutable collections, you have collections. They look and feel like Java util lists, but they're different. So can I get a Java util list out of this? I think I can, right? Let's see. Let's see if I can type to list. What does that give me? It gives me a what? Oh, it's giving me a Kotlin's collection list as well. And that in turn is a collection. Well, that's a bummer. Yeah, there's got to be a way to get a. Is this a Java util list? Like, I don't even know. Because it's not like I ever care. Print print line collection is Java util.list. Oh, cool. Oh, yeah. Split. It's trying to help. It knows what I'm trying to do is wrong. Yeah, so it is a Java util list eventually. There's some magic there, right? Like, so let me try Java util set. Like, that should be false, right? Yeah, so it's a Java util list. By the way, this is the instance of operator, right? In Kotlin, I should mention. Okay, so, pretty powerful. You've got map, you've got filter, you've got the usual niceties there. Filter, first or null, first, bind. Actually, it's pretty robust if you think about it. This is like, good stuff. Okay. Map, list, last, first, that kind of stuff, right? All this stuff is just provided for you out of the box. But again, it's really nice. Did I cover flows with coroutines? Not yet, because I want to. Let's cover the reactive stuff because I think it makes more sense in that context. Yeah, but that's a good question. We'll cover flows when I can show a flux, then I can show a flow. Right? It's much easier. Those are a cool collection. Yes, true. Okay, so no, we're gonna do it tomorrow. We'll do it tomorrow because I don't want to it just makes more sense to be able. I can do flow of right now, but I would have to do the whole. Let's just cover it tomorrow. That's more fun tomorrow. But you're right. It is a very cool collection. Yeah, they are. That's true. So because remember, Kotlin has multi-platform, so the implementation is going to be platform specific. So they have these interfaces that kind of keep you ignorant or unaware or indifferent to the underlying implementation. If you're using JavaScript or if you're using something else, it might be different. So that's cool. What else do we need? I don't know. I think we got a lot today. I don't really want to drag in the coroutines and reactive stuff just yet, but I do want to talk about it. So maybe we just call it good for the day. It is my day off after all. It's not like you can see out in the weather. It's not really very pretty outside, but maybe I'll go sit in a park or something. It's kind of horrible. I have the day off for work, but my kid is at school and my partner is at work, so it's just me and my friend hanging out today. So I think I'm gonna go do that. We'll do reactive and coroutines tomorrow, which is where I start to, where they start to because what they mean for Spring development and for reactive programming is that you can use the best non-blocking approach to writing code with the same ease of understanding as imperative blocking IO today, right now, and you can run on Java 8. Well, with Spring Boot 3, you have to run on Java 17, but you get my point, right? In theory, you could compile against. You could take coroutine code in Spring Boot 2.x and run on Java 8 and get this very clean, easy to understand imperative. Line 1, line 2, line 3, as opposed to this chained approach. I don't mind the chained approach, the method chaining for reactive programming, but I understand that a lot of people don't like it. So let's just call it good for the day, my friends. We'll pick up here tomorrow, bright and early, as always. I appreciate you. I hope you're having a great day, and I'll see you tomorrow. Bye, everybody.